entire network. Duality. Duality is a tool to understand a particle which is organic enough that it has maximum entanglement entropy. If the particle is organic enough that the network happens among the entire body of particle, then the particle has duality, which means two contrary properties are true in one system. The system can be well understood within feedback system. Feedback system is a good tool to understand duality. Entanglement entropy is a good tool to measure how much two regions are entangled. The maximum entropy is limited, which is the value for duality to exist. And I'll show that what is entanglement entropy. Consider a quantum system that is divided into A and B, two parts such that the full Hilbert space can be represented as the tensor product of the Hilbert spaces of A and B. A typical wave function of this system is psi. In each A and B in the state psi are entangled, since psi cannot be written as a simple product of those A and B. Entanglement entropy is a measure to quantify how much A and B are entangled. Define the reduced density matrix of A by tracing of a B state is in psi. Then entanglement entropy is defined as this. From the definition, an obvious corollary is this. Indeed, for any pure state psi, we can always write it as this. By geometric composition of psi into some complete set of S A and B, it follows that SA is SB. For AB composite system in a mixed state, in general we have SS not SB. In such a case, entanglement entropy typically contains classical statistical correlation of the mixed state in addition to quantum correlations. Here are some examples. A two-spin system. You can have a state that is not entangled. However, the state is entangled. For this state, the reduced density matrix for A is this shows entanglement entropy is this. We see entanglement A has period of this. The minima are SA is 0 when theta is n pi over 2 and maxima are SA is log 2 when theta is n pi over 2 plus pi over 4 where n is integer. A maxima of state psi is most integer. We list some important properties of entanglement entropy as follows. Suppose A, B, C are three parts of the system without any intersection between any two of them. We have subadditivity and strong subadditivity. Entanglement entropy plays an important role in quantum information and quantum computation as it provides quantitative measure of quantum correlations that are not present classically. Entanglement entropy in many-body systems. Consider a system AB if Hamiltonian is H equals HA plus HB, then the ground state is unentangled. Moreover, starting with a general unentangled state, the system will remain unentangled. If we add coupling between A and B, H is HA plus HB plus HAB, then the ground state is generally entangled. Thirdly, starting with an initial unentangled state, entanglement will be generated during time evolution. In all realistic condensed matter systems and quantum field theories, HAB is local. Heisenberg model and 5/4 powers quantum field theory. Locality implies that the interaction only happens near the interface of A and B. So HAB only inverts degree of freedom near DA and DB. This has important implications. Locality of interactions. One finds in general in the ground state for a local Hamiltonian, entanglement entropy is given by this, where epsilon is the lattice spacing for CM system or short distance cutoff for quantum field theory, which characterizes the geometric width of interface. This formula shows that entanglement entropy between A and B is dominated by short-range entanglement near DA, where HAB is supported, while 16 appears to be universal, sharp is not. Depending on short-distance physics of specific systems, for the subleading order terms, the excitement of last decade on entanglement entropy shows that they come from large-range entanglement and can provide important characterization of a system. Characterize topological order 2 plus 1 dimension in typical gap systems. Ground state contains only short-range correlations. In topological order systems, ground state contains long-range correlation and not accessible via standard observables such as correlation functions of local operators. The entanglement entropy for such a system is this, where gamma is not zero is topological order, a constant independent of shape and size of A. To characterize the number of degree of freedom of a quantum field theory for a 1 plus 1 dimensional CFT, there's no leading contribution, and one finds this where C is central charge and L is the length of A. We know C contains the information of number of degree of freedom of a 2-dimensional CFT via Cardi formula. For 2 plus 1 dimensional CFT, one finds this where gamma, depending on the shape of A, can be used to characterize the number of degree of freedom. Similar results can be found in other dimensions. Holographic entanglement entropy. Suppose we have a CFT with a gravity dual. How can we calculate entanglement entropy on gravity side? As shown in the picture below, we propose to find the minimal area surface of gamma which extends into the bulk with dA as boundary, and entanglement entropy is given by this. This formula was first guessed by Liu and these who were motivated by black hole entropy. Minimal area. There are some support for this formula. One, satisfy the strong subjectivity conditions. 2. Reproduce known results about entanglement entropy. 3. Give many new results that are sensible. While easy to define, entanglement entropy is very complicated to compute for a general many-body system. Even for a free quantum field theory, the computation is highly non-trivial and often numerical calculations are needed. RT provides a very simple way to compute entanglement entropy in a class of strongly interacting quantum field theory. Here are proofs of strong subjectivity. In figure 3a, we can classify this. And by definition of minimal surface, which implies this. In figure 3b, we also have this. And by definition of minimal surface, this, which implies this. Now we can apply this formula to 1 plus 1 dimensional CFT whose duality is 3, where the matrix is. We know each CFT is characterized by a central charge C, density of state, and the trace normally gives this, where R is Ricci scalar. For holographic CFT, the central charge is given by this. On the gravity side, like Wilson rule, we consider constant time slice where the matrix is, assume the minimal surface is a function of xc. The differential length of the surface is this, consider right half is this, and extreming it leads to the random answer, the half circle with C0. Finally, we get entanglement entropy, where epsilon is the cutoff to regularize the divergence. Clearly, this result agrees with the calculation from CST. In finite temperature, we may discuss the connection to black hole entropy. Consider the CFT on the circle. We should recover black hole entropy if we take A to be the whole boundary space between by definition. Because by definition, as the thermal entropy, and in this case, the reduced density matrix is the same as the real density matrix of A. Indeed, graphically, the minimal surface is just black hole horizon and black hole entropy is recovered. Generally, if the minimal surface is always perpendicular to boundary, area law can be proved in edges in arbitrary dimensions. RT formula not only provides the simple way to calculate entanglement entropy, but more importantly, it implies some connection between space-time and geometrization of quantum entanglement, geometry, and quantum information. In the end, we may expect a unified paradigm. Theory. Within the ADS-CFT correspondence theory, the information can be recorded as CFT and ADS. And ADS is about gravity, which is related to particles. CFT is about surface, which is related to wave. Now I will explain ADS-CFT correspondence theory. In the ADS-CFT correspondence theory, the gravity of Borg, which is expressed as ADS5, is expressed as a wave information of the boundary, which is expressed as CFT. And there should be a homeomorphic correspondence between ADS5 and CFT. And the way to show this relation is same as the way we prove SVD is 5-dimensional. When particle gets into a black hole, it has a topology of surface of sphere multiplied by hyperbola. It means a particle gets absorbed by gravity, which explains hyperbolic topology. The particle has a wave effect, which explains spherical topology. In this way, particle has a mechanical energy as wave energy and gravity energy. So gravity energy can be expressed as wave energy, and wave energy can be expressed as gravity energy, which is edge-safety correspondence theory. And this uses spherical system when it is about wave energy, and this uses hyperbolic topology, which is about volume divergence. So this is same as the way I proved this 3D is four-dimensional. As you can see, black hole is a particle which is entangled maximum, so it has duality many properties. And in edge safety correspondence theory, the information of edges would be transferred to safety light velocity, but the light velocity in black hole is close to infinity, which is much faster than the one out of black hole. So the information of edges is transferred to safety much faster than light in black hole, but there's no particle which satisfies it except tachyon. So only inside object which has maximum network to have duality, Tachion exists. So Tachion can exist inside the electron too, but Tachion cannot get outside of electron, even the electron or black hole get vanished. And Tachion should have duality, so when Tachion crosses near us, it will be seen as two situations. One is seen as Tachion crossing by, and the other is seen as Tachion going back. So Tachion is an organic object because it has duality.